So my name is Andreas Hammarskjöld. I come from Sweden, and next to me I have Narkis, and we're going to cover delivery optimization. It's going to be a lot of demos. Some of them might not even work, so we'll do a little bit of debugging live on the stage, you know, the way that you like it. But we hope that it should all be good. This is our contact information if you need to get us after anything or have any questions that you can't get any answers to during the session. It is a pretty deep dive session, so if you expect marketing material, you're probably not going to get too much of that. So we'll try to feed you the real deep technical stuff instead. But we're going to show what you can do with delivery optimization today, what you can use and play with and take home, and what's actually coming, and that's pretty much it. So we're going to be talking about, there's 3 different types of peer-to-peer folks that Microsoft got going at the same time. The key message that we've been trying to get out is use one of them. If you attended Michael Niehaus' session the other day, he pointed to, it's really important that you do one of them. Which one doesn't matter as much, but at least that you're doing one of them. So, but there's one session tomorrow that I'm doing around branch cache, and today it's all about Doris. So, handing over to Doris.
Hi everyone, I'm Narkis. I'm a program manager at Microsoft. I work with a great team of engineers out of Redmond, Washington, all dedicated to working on delivery optimization. So what it is and why you should care about it and what makes it unique when you compare it to branch cache and peer cache. So delivery optimization is a distributed cache. It means that we're using clients on your network, devices that are on your network as alternative sources to download content that comes from Microsoft. So clients start downloading, they store a little bit of what they downloaded in a dedicated cache on their device, and as new devices come in, they find these other sources. All of this is orchestrated by a cloud service. So we have delivery optimization services up in the cloud that these clients communicate with to find these peer sources. Now, delivery optimization is a hybrid client. So that means that it's capable of doing both HTTP and peer-to-peer traffic in parallel. So it starts through the reliable HTTP source of your choice. So if you're working with directly with Windows Update, your customers of Windows Update for Business, then your download will come from Microsoft Cloud, from our distribution servers. If you're working with WSUS, delivery optimization can work against that. And if you're working with Config Manager, right now there's one option for you to use it, and that is if you're using Express updates. So delivery optimization starts with the HTTP source, brings a little bit from that source, and in parallel it opens multiple connections to those peers that are offered to it from the cloud. Now it's capable of adjusting dynamically to the network that it's in. So if a peer disappears, my device downloading from your device and your battery dies, that's fine. My PC is going to keep downloading from other peers and adjust dynamically to that. If I can't find any peers, I'll just download from the HTTP source. Now, given that we're using LAN peers to download, the download itself is going to be much faster. And you're going to see that in a little bit. At the same time, one other thing that delivery optimization does is download the updates in very small chunks that we pull from these different sources. And as we bring down the chunks, we're able to verify each and every chunk and make sure that the hash is matching what was previously ingested into our systems. So if even a little piece is corrupt, we just automatically re-download that piece and continue from where we left. Today, in a typical download, what would happen, even if 1 megabyte is corrupt, you'll finish downloading a 3 gig upgrade, and at the end, you'll have to re-download it because it's corrupt. So these are kind of the key benefits and key differentiation. So how does it work? The first thing, the content needs to be published into our system. And the act of publishing, you don't need to actually upload that payload. What we upload is just metadata. That metadata is comprised of the chunks and the hashes of all these chunks. We generate this, what we call the DO metadata. And you'll hear me saying DO, the shortcut for delivery optimization. So this is the metadata that we must have in order to do a peer-to-peer download. If we don't have that metadata, again, we go back to just doing a plain HTTP download. The content that we support today is anything that's coming from Microsoft Windows Update. That includes OS updates, so feature update, quality updates, security updates, so Defender definition files, drivers, and then anything that comes from Windows Store, so apps and apps that you're using through the Windows Store for Business if you've opted in to use that. So after we publish, now come the time to download. So it all starts with the client talking to the Windows Update service, trying to find out if it has any update available to it. Once it finds that update, it gets from the Windows Update service the HTTP location of choice, or if you've configured it to use some local source, it's going to know to attach to that source. But in parallel, it's also talking to the delivery optimization services and getting basically the suggested peers to talk to. So in this case, I have clients B and C, and those clients already started downloading. They're downloading in a random order, so they might have different pieces than what I need, or not everything that my client A needs. But it's going to start pulling, so it's going to pull some parts from the HTTP source, some parts from the other clients B and C, until it completes the download. And it's going to verify, again, all these chunks that come from these sources, put them together, make sure that the entire file is what we intended it to be, so it's authentic, and only then proceed with the installation of this package. Now that the download is done, the file is stored in the cache. And as long as the file is there, the client is going to keep talking to the service to say, I'm still here, and you can use me as a source. If the client, again, disappears, the service knows not to offer this as peer to other devices. Once the content reached an expiration, so we have default expiration for content, and I'll talk about these default behaviors in a little bit, but once the content gets expired, this device will no longer speak to the service. So,
all right, perfect. Let's do a demo.
8.
All right, so Narkis covered a little bit, and I actually set up one of the demos that I was going to run right before you guys came in. The problem is delivery optimizations run extremely fast. If you're a little bit familiar with branch cache is more of a slow guy. He transfers, trying to keep things in the background. DO can be extremely fast. So it actually grabbed the content and finished in like 1 second. So the demo wasn't very good. So we might see a lot of that demos are a little bit too fast, doesn't work. So we might rerun it a couple of times. So my favorite things there's 2 types of sources, as Narkis said. This Windows Update is really boring to see machines rebuilding all the time. To see that's typically when you get a lot of DO activity from getting the patches, getting new apps, etc. So I go to the store and I find interesting things that are for free that you can download that are of a considerable size. Typically that's racing games. So what sits this better than, well, this wasn't that big. It was about 70 meg.
Oh,
so
yeah, that's too small.
Well, probably a good one to start with. So what happens here when you do this, you get a little bit of feedback in the hub. But if we go to the background, we should be able to see if I format this to a table, you basically get a bunch of information. And I think I zoomed in a little bit too much here for you. But you'll be able to see these PowerShell commandlets gives you back, sorry about the layout here. Maybe do it a little bit different. There we go. So get delivery optimization status and get delivery optimization perf snap, if some of the things that you get, to be able to show you, and you can add verbos, and you see there that's the game actually got installed. So here are some of the stats that you want to be looking at when you're playing around with this technology. So total files download, pretty easy, but you can see also that we have upload stats, which means that we've been feeding data. So if I go to my status, I should be able to see, probably missed some of them. But like this is one of the guys. I think this is the guy that I downloaded, that I wanted to download. But it basically ran too fast. So you can see no, that's not the one, because that's HTTP.
Yeah.
No, it's on the other machine. Hold on, so let me switch. So I got two machines, so it might be a little bit confusing. So here is my other machine where I ran the actual download that completed in a second. And you could see that everything came from my group peers. And that is basically, if you're using grouping in DO, we'll cover this more in details during the presentation, where it actually got the bytes from. So you got a pretty good control of saying, should it come from internet, behind your NAT, or individual group IDs that you define yourself.
And you can see up there that it got about 2 megs from the HTTP source, because it always starts there, but as soon as it discovers the peers, it's going to drop the HTTP connections in favor of this really good peer that we found.
Yeah. This is a question for you. Does it include the hash download in the stats?
No.
So
no.
No.
And that is a ratio to the file size. It's much tinier than 2 meg. Yeah.
But it's pretty good. You can see that it's almost 99.9% from the actual peer itself. So that's pretty much it. And so if we go back to the slides a little bit, or was there anything else that you wanted to show around this?
No.
No. Okay. Which one was it? Up?
5.
5? Perfect.
Okay. So we designed delivery optimization to work out of the box in consumer scenarios. So in your home, like me, you probably have multiple machines. And all these machines usually pull the update all the way from the cloud up until Windows 10, where we introduced delivery optimization. And now, without you configuring anything, with DO's LAN peer-to-peer, we're able to find these clients and really reduce the bandwidth that we're using in your home. Now, we fine-tune that for these types of networks, but when you as an enterprise start looking into it, you probably have more interesting network topology that the default settings might not work for. So for that, we have a set of policies that we expose for you to help us better understand how to pick peers on your network. So I'll go over all these settings, but this one setting that's specifically configuring the download strategy, it's called download mode. The other thing is we have all kinds of policies around bandwidth limits. So if you want to restrict bandwidth in some sites, we have policies around that. You can use that with or without peer-to-peer, and I'll cover that in detail. And lastly, the cache. The more opportunity you give us to save content in a cache on some devices, the better we'll do on the peer-to-peer side. So again, by default, tuned for consumers, we expire content from the cache pretty quickly, but you can extend that if you know you have a machine that's a beefy machine sitting in some lab and it can store content longer for us. So moving on to download mode. So download mode, we have a bunch of options in the 15.11 build. These were the options that we exposed. You either use HTTP plus LAN, and that means that you allow peers on the same, that are behind the same NAT, and that's the default option that we enable in Windows 10. There's the option to enable the group mode. And group mode is where you're saying, okay, I want to expand beyond just the NAT. Maybe I have multiple NATs in a single office, and I want to have more peers and peer-to-peer activity between those NATs. So this is when you use that one. The third one is internet, and that really means that if you enable this, we can peer with any device around the world. This option, even if you set it, it's really enabled only on insider builds, right? So if you wanted to see how it's working, we'll be selecting peers based on geographic location in this case, and this is something that we're testing in the insiders environment. The last thing is mode 0, HTTP only if you're in build 1607. So we really changed the meaning of it between those builds. So in 1511, if you wanted to skip DO completely and not use it, you would set 0. But we changed the meaning of it to basically use DO, but without peer-to-peer. So that's the meaning of it if you're on a recent build. And then we added another mode. So the difference between the two blue modes you see there, 0 and 99, both are using HTTP. The only difference is that metadata that I talked about. So if you're downloading in mode 0, we're still talking to the cloud to get that metadata. We still do the piece level, the chunk level verification, but it's still a pure HTTP download. If you're not interested in that, if, for example, your devices are in an disconnected offline environment, and you don't want these downloads to wait on the client to understand that it can't reach the server, or it's disconnected, and waste all that time starting the download, then the recommendation would be to set download mode 99. And lastly, we have the bypass mode. That's mode 100. And this is where if you have a scenario where you're using branch cache, and for that you need to use bits, then this would be the mode that you should set. So group mode. If you enable group mode, we're going to try and find peers in a greater area. So the default grouping that we have is to see if you have defined an Active Directory site in that environment. If the client can detect that the client is belonging to some Active Directory site, it's going to use that by default. If it can't find that, it's going to use the authenticated domain and group all devices that are authenticated to that domain as a group of peers. But if none of these options work, there's another policy, and that is the group ID. And with that, you can create your own GUID and just basically create the groups however way you wanted to create them. So to give some examples. So this is the default. Your clients are breaking out to the internet using different public IPs. And by default, if you enabled the LAN mode, the mode number 1, then these clients will be communicating with each other behind the same NAT, but clients coming out from different public IPs are not going to be talking. So if you want to create a bigger group that contains all of these, then you would enable the group mode. And now we're able to basically have peer-to-peer connectivity between those different sites or different subnets.
Is there anyone in here using group mode today? One guy? Two? What are you? Anyone
Microsoft.
Else? Yeah.
Yeah.
So we strongly recommend you, if you're not doing that today, to look into it to see whether it fit. And it could be with a combination of the other policies as well. It doesn't have to be something that you apply across everything, but
yeah. So at Microsoft, even 2 machines in my office use different public IPs. So if we didn't have that MSIT deploy that, we wouldn't be seeing a lot of peer-to-peer activity with the default option. So MSIT pushes the group mode to all Microsoft employees around the world. So this is another example. If your devices are breaking out through different public IPs and they're on different domains or different sites, you set the GUID to basically join all of these clients into a single group. And the opposite of this example would work as well. You could, if you wanted to, if both of these were using the same public IP and you wanted to ensure that they won't be peering with each other, you'd set different GUIDs in these different sites. So a little bit about the cache. We by default, take 20% of the free space on the device. So it means we constantly look at how much free space, if you're starting to download a big file or copy a big file, our cache is always going to make sure it's under 20% of the free space. There's a policy for you to change that if you want to either increase that percentage or even turn the cache to use an absolute cache size. Content, we keep it there for anywhere from 24 hours to 72 hours, sometimes even less. It depends on the file size. So again, if you have machines somewhere that you can store the content longer, we offer a policy for you to extend that. And lastly, we do purge the content from the cache, but we don't just take the oldest first and throw it away, and we don't wipe out full files. So what we do is we leverage the cloud service to bring down some knowledge about what are the most popular files. So if you have some package that all your users on your network continue to consume and it's a popular content, that content is going to stay in the cache even though it was created, it's older, right? The second thing that we do, we consider the cache as a distributed cache. We want to try and have as many sources. So even when we need to expire the content, we don't delete the full files. We start purging random parts. And so the more users you have, the more chances we'll find some pieces that we needed with peers on your network. So let's see on the policies, there's the last policy there is one where you can modify the default drive. So by default, we go to the system drive. Again, if there's an attached big drive that we should use, this is the policy to let us know about it. Moving to content and device policies. So again, there's default behavior. If the content is in a certain size, it's 100 megabytes in older releases, but starting in 1703, anything above 50 megabytes is going to be using peer-to-peer. If it's anything smaller than that, it's not going to even attempt to do peer-to-peer. It won't talk to the service to find peers. It will just do a plain HTTP download. Same applies for the disk size. If we don't see the device as a good candidate to do peer-to-peer, we just make the decision to switch to using HTTP. And again, this was fine-tuned for a consumer, but in your environment, you can lower that. So we expose a policy for you to tell us to do peer-to-peer on any file. If you wanted to set it for a minimum of 10 megabytes, you can do that. If you want to allow devices with smaller disk size to participate in peer-to-peer, you can do that as well. Okay. So we were going to do the storage, but
Yep.
I think you, actually, no, you didn't cover that yet. So
No, we haven't covered that, so I'll cover that in a
yeah.
little bit. I just want to show, so what's running at the demo at the moment, I started GT Racing 2. It's about 1.1 gig, so this is, we'll be able to track this. It was in the dashboard, I just paused it because it was going a bit too fast, so it'll come back in again. You can see that it's downloading at about 10 meg at the moment, so here it comes back in again. So we'll cover more of this in the detail. I just wanted to show that this is now downloading on one machine, and we'll do the demo later on the other machine to get the same content, and you should see it just fly. So if I go to my other machine, basically this is a 1709 build. Mm-hmm. The cache location is moved to C Windows Delivery Optimization, and if you really care, it's basically, might be a bit, the font's a bit big, but it's all in the hash structure, and as you download content, it will basically populate these, and as it purges content, these GUID structures will, get smaller and smaller. So it kind of evolved during time.
So all these folders with the 0 bytes are probably files that were very small. So we download them and then we expire them right away. So that left over there is going to disappear the next time the client restarts.
So here are some of the caching group policies that you can set. So you can modify the cache drive and set minimum RAM capacity is something that's quite funny. I lost a couple of hours on that yesterday working on VMs to do this demo, and I forgot to set the limit. By default, it's 4 gig.
Yeah.
So if you don't have 4 gig of RAM, which you're typically maybe not having your VMs, it doesn't peer-to-peer. So I was sitting there scratching my head, why is it not peer-to-peering? So especially if you have a few beers, then you know, you're not the smartest. So.
Should have called me.
Yeah. Well, I read the deck. So always remember that. But here are some of the other policies that you can set about caching. Let's see if I can zoom in. Yay.
You're
So
braving the
I'm
Zoom
brave,
again.
Yeah, I'm not using zoom in anymore. I'm using the magnifier. So. But these are some of the policies that you can set to make sure that you use, you know, as much data as possible. So there's quite a lot of policies that you can set around the caching stuff. And also together you can set the absolute max cache size. So, which will kind of cap the percentages if that comes in before. Cool. I think that's it around the storage policies.
Okay, so bandwidth throttling, my favorite. So this is something that I've heard from many customers, where the available policies that you have in bits today to throttle downloads are not really helping in an environment that's changing with the user. The user takes their laptop, they're in the office, they go home, and you don't want to set kind of an absolute cap on their speed because they get mad if they have a really fast connection at home and they can't use it. So for that, we created the ability to throttle as a percentage. And so you can set it as a percentage. You can use the default that we have in the system. But essentially, you can cap it, and that assures you that we're going to basically adjust to the network that the client is on. So you can set it as 40%, and the client is going to dynamically measure as it's downloading and adjust to ensure that it's using under that 40% that you set. Now, if for some reason still an absolute cap is what's required, maybe it's a policy that you apply as the device is on premise and you remove it when they leave, you can still do an absolute bandwidth throttle. Okay, so we're going to move to some best practices because we have all these policies. There's great documentation written by my colleague here. And while you can read about what the policies are and what they do, still you probably want some guidance. So we're going to talk about some best practices for you to try.
Yep. So we kind of covered on the first one already, is to use the actual group ID to define your machine. It's absolutely the best way that you can control it, where it gets the data from. So you can also use the group ID if you don't define the actual ID, but you put the machine in group mode. It will use Active Directory as your basically a boundary of where to get the data from. And if you have defined Active Directory sites, it will actually use that as well. But setting the actual GUID ID gives you much more detailed control.
Yeah, and there are some examples there for things you can attach to basically assign the group ID to something that's matching your site or the way you want us to behave and not use expensive WAN traffic for peer-to-peer activity.
Yeah.
And another way that's not listed here is eventually to block the ports, but that makes us a little bit sad. So please try to avoid it.
Yeah, and I think we'll probably try to do a couple of blog posts of examples of how you can control this using the group ID, because there's some really cool scripting stuff that you can do that's not too complicated and works really well. So kind of the other best practice is it really depends on your network topology, but if you have thousands of locations, but a lot of them have pretty good internet pipe, you should be able to use that and just put it in default grouping mode, because it doesn't really matter where it gets the content from. So that built-in functionality is actually pretty solid and pretty good.
And you might have your update scenarios already managed by a config manager or Intune, and maybe you're using something else to reduce the bandwidth there. Maybe you're using WSUSs or local DPs. But still, there are some scenarios that come in that are not currently supported in any of these tools, and Windows Store apps is one good example. So we have a lot of built-in apps in Windows that will update automatically unless you actually made the effort to block it. But if you enable delivery optimization, you will leverage from that scenario. And really any new scenario that comes into Windows, because we're part of the kind of the main stack of downloads in Windows, if you enable it, it's going to keep supporting new scenarios. And I'll talk about which scenarios are currently supported and which ones we're going to be adding.
Who's running Config Manager in here? Yeah, good.
Solid.
Good show of hands. So you really want to enable DO together with Express. I think it's a little bit undocumented feature.
Yeah, because it came out pretty recently. It's in the 1706.
Yeah, so basically
SCCMPM here is
what DO will
broad.
do is that DO will tell the Config Manager client to go get the data from the DP, but at the same time, in parallel, it will actually try to find peers that has the same data. So if DO finds data faster than that comes through the DP route, the Express download will be a lot quicker. So it's a really cool way of getting using both the built-in like bits, branch cache, and that side, as well as DO in parallel to try to get the most out of the peer-to-peer stuff that you got.
Yeah, and one added benefit to Express if you're not using it yet is the payload size that clients need to bring down reduces significantly. So you're really kind of piling on with lower payload size, but also peer-to-peer on top of it.
Yeah. So the other best practice is if you have devices that you know that you can use that have big disks. Some people like have a mini DP or things like that. You can then define them to set that they can have. Maybe they have a secondary hard drive that can use to cache. Use that space. Enable it and just bump up the policies for that machine.
So we have a specific policy under extending the cache age. And if you set the value of 0, and if you click to the next one, so these would be kind of the recommended settings for those preferred machines. And all you're doing is just saying, extend the probability for these devices to be used as pure sources. So if you set that 0 for this, the max cache age policy, that tells our services that this is a client that we should be offering more often. So we typically try to kind of distribute the load, right? So we pick the peers in a random order. But this is kind of pinpointing at that peer and saying, you can abuse it a little bit more, right? So that's what this does. And of course, if that's the machine that we should use, it would be a good idea to also extend the cache and the cache size and use an additional drive if it's available. Another important point here, if you are considering WoofB or piloting WoofB and you've set up your rings, your deployment rings, and by the way, there was a presentation that Sandeep and I did yesterday about Windows Update for Business. So if you're not familiar with that, please go back and watch the recording. But basically, the notion of Windows Update for Business, you can set those deployment rings. So you have a group that is kind of your test pool where you get those devices to download the latest release and see that everything is working as expected. So really leverage that test pool to push these policies, and this will be your pre-cache population for delivery optimization. Now we generally say, and we had a long discussion about that, we generally say just let things happen in random, because randomness is always generating better results. We think of DO as a technology that's self-organizing to adjust to your network, but this should work as well, and this should increase the what we call peer efficiency, how much data we're able to pull eventually from peers. Okay, and lastly, I think I mentioned that when I talked about download mode 100, the bypass mode. It's there if you are already using branch cache. We don't want to get in the way of that. You have to use bits for that, and so make sure to disable DO. It means that all your downloads will go through bits. if that's your method of choice. So if you're not using peer-to-peer today, or you've decided to try delivery optimization and it's not working the way you expected it, we want to know. So I really encourage you to use the feedback hub in Windows 10, and maybe we'll switch just to show where it is, if you don't mind.
Yeah.
The feedback hub. But we also created this email alias that gets back to our team. So if you have some thoughts, suggestions, you've tried things and it's not working, we want to know. But just, the feedback hub is a great place to not only submit your feedback, but also tell us when things are not working as expected. So if you go to feedback, how many of you have used the feedback hub before?
Awesome. A few hands, yeah.
Awesome.
Use it, it's good.
Okay, so if you mark it as a problem, and then you select from the categories here.
So if you mark it as a problem, it becomes your problem?
It is my problem and I care about fixing it. And then, okay, so these are the categories: Windows installation, update and recovery, and then subcategory Windows update. What this does, if the problem happened on that machine, it's going to pick up all the necessary logs that our team needs to be able to look into that and see if it's something that we need to fix or if it's a configuration issue. So please use that. It's a great tool.
So who's using peer-to-peer today? Only a few hands. What's the rest of you guys doing? Just painfully downloading per machine? Aren't you bored of that? A little bit? Yeah. Okay,
so here are some instructions. If you wanted to try it out, it's really the simplest way to do is to set some of these policies that we talked about. Open the store, download an app that's bigger than 100 megs. There's really cool games that you can try as you go. And wait a couple minutes, do it on another device. It's not required. It should work even if you start the download right away. But to get to see these big percentages, wait 5 minutes. And then you can use the PowerShell commandlets to see how much data you got from the different peers. Another thing we have is a UX that we added. So this is in 1709, and this is for any user to have easy access to see what's happening on their device. How many bytes we're downloading from Microsoft, from our HTTP or your HTTP server, how many bytes we're downloading from peers on your network and peers on the internet. We also give you kind of statistics about the download speed in interactive downloads and in background downloads. And then also the upload statistics. This is relevant to the internet scenario as well. So we measure how many bytes we send to random PCs on the internet if you wanted to try it out on the insiders builds.
So just to show you guys where it is, if you launch settings, you go to update and security, and you make your window a little bit bigger. Then you go to advanced options. There you got delivery optimization. And then you scroll down. I missed that a couple of times. And you look, you got activity monitor down there. So if you click that up, you should be able to. And
if you type in the search delivery optimization, it's going to get you closer to that window that's buried down there in the settings.
So let me try to move my magnifier out of your way. So as you can see, this is a pretty cool way of actually tracking what each individual machine is actually doing. So
yeah, and that's going to keep tracking the data for a month-long period, a calendar month. Yeah. So this is your way to kind of go back and see what the device did. Even if you just want to see, if you didn't use peer-to-peer, you can see how much data we're pulling down.
Is the registry key? Are the registry keys going to be fixed? Do you think?
Which registry keys?
Showing the data? No.
No.
No? All right.
Registry is not a recommended
we'll
way.
We'll come out with a good way so you can actually inventory this using Config Manager, so you'll be able to track it on a more.
Yeah, and the same data is exposed in the PowerShell commandlet. So the perfsnap commandlet is going to show you that monthly summary as well.
Perfect.
I'm going to switch back to the...
I think the next...
yeah. It's just a
this
slide that says visualization and analytics, so
yeah.
that's what we're going to look at.
So now let's try to do something a little bit more advanced, like zooming out, for instance. All right, so the company that I work for, 2 Point Software, we try to do real-time management of delivery optimization, branch cache, and peer cache, and basically all of the peer-to-peer, and as well as other network technologies. So we're super excited to work with DO and to give you a kind of an enterprise view of what all the downloads that's going on. So we're going to try to use, this is beta software, pre-release software on pre-release software on pre-release software. So if it all falls apart, and it might also be a little bit too fast, but what I want you to look out for is these values here, because they're going to show you how much data is coming from the WAN and how much is coming from the actual local LAN. And then you could drill in. But probably what you're going to see is that the download is going to be extremely, extremely fast, and we might not be able to catch it. So my download completed fine earlier, the one that I was tracking. And if I go on to my other machine here, and I go in to basically get the same stuff. So you should see it starting, doing the download, and hopefully it takes a little bit of time, so we'll be able to catch it.
It's saying downloading, but it's not really starting to download yet.
No, so store downloads they're a complex beast because it checks all of the requirements of the actual app. Like, do you have the .NET framework installed? Do you have that installed? Do you have that installed? And then builds an actual list of things that it needs to install. So hopefully.
Oh, this is taking a little bit longer than usual.
I'm hoping that's a good thing, that we'll be able to catch it. It's always one of these demo things, right? It's like if we don't look at it, it's going to go.
Don't look.
So hopefully we didn't lose network connectivity during this time. I don't think we did. All right, I took some pictures of what you're going to be looking at, though. So maybe if I show the pictures, it's going to start moving. Yeah, so let's look at the actual picture. It will probably start going here in the background. So this is some of the stuff that you'll be wanted to be looking at, is that the actual, you'll see that it's doing both transfer from WAN as well as getting it from the LAN. So DO's, the way it works, it will use a lot of different sources. So you can get stuff from your LAN peers, you can get stuff from your internet peers, you could get stuff from the actual source. And if you're on a good connection with really good connection to the server, there might not be peers that's responding fast enough, and you get the content, all of it from the server. So it's really intelligent the way that it's actually getting the content. So.
And the more peers you have, the better chance it has to find those peers and connect to them and start downloading. So here we're kind of pre-caching one peer and having the other peer find that one peer and try to download from it. So we're challenging it a little bit.
I was getting it.
Oh.
Not sure it's peer-to-peering though.
Because it's too slow. Yeah.
It might be that the link was too slow. Or it might just kick in a minute. But here you can see, so this is what we didn't want to show. So that it should, which is always good for a demo. But it gives you a way, like if you're testing it out, so and you get bored of using the PowerShell commandlets to see where the content is coming from, it's a good way to actually visualizing it in real time. So we will release a free version of this so that you can be able to track all of it. It's read-only, so it won't change any policies, but it will give you like a very good view of where the content is coming from. It's taking us a little. There's been a lot of changes in the Windows releases, so we've been struggling, but hopefully we'll get everything right for the 1709 release when that comes, so that you'll be able to use that to actually track it. So did I download the right thing? Because there were 2 of them.
Yeah.
Let me cancel that one. Which one was it? Because I think I downloaded the wrong one. And of course, if you're doing that, there's a lot of games that have the same, that look exactly the same. You can see this one seems to be going, yeah, look at that. That's a bit different, right? So if we're lucky, we should be able to track it in here. It should come in with enormous, the dashboard is already a couple of seconds behind, but here you see it actually got the WAN speed in, so you should be able to see soon here, like wang.
So the green is the bytes that are pulling from peers?
Yeah. So basically this is still showing some WAN speed, but I know it's not coming from that because it's going so fast. So this is probably our software that's not picking up the changes. Let's slow down a bit.
So we can go back to the PowerShell to show when it's done. Yeah.
So if you run the actual statuses, this is where, did you want it for the actual download?
Yeah.
Yeah. So if I go back to my client, and PowerShell. So here's where you can track. So this is the job that we're doing. And if you go up, you can see it's actually downloading. So no, it didn't get it from the peers. Maybe I clicked it, maybe I did the same one.
Okay, so let's move back to the slides and
Yep.
we can give it another try. Okay. So
yeah, so this is basically the stuff that we talked about. So you'll be able to track regardless of the source is coming from. So you'll be able to see that there's the DO stats are extremely good. So they typically go up to about 99, 98%. So extremely good. There are some types of apps, if like it has a ton of small files, we don't really try to cache them because it's more inefficient to try to do peer-to-peer on very small files. So there you can see a lower percentage. But often a lot of these like store apps are typically large blobs. So they're pretty good to test it out with.
So we realized that seeing reporting is critical for you to know if it's working on your network, because the configuration applies the way you intended it. And so for that, we're working on adding dedicated data, aggregated data for delivery optimization in Windows Analytics as an OMS view. So this is coming pretty soon, couple months, I hope. And what we're planning to show is really an overview. So across all devices in your organization, we give you the box there that's in red is to show how much bandwidth you're getting from peers for your quality and feature updates. So that would kind of give you a quick view on that. And then the rest of the data drills down to the different content types. So you can see how much data you're getting from peers for different content types, for drivers versus OS updates. And you can see exactly the type of the peers that you're pulling from. So if you set up a group, you can see how much bytes you're getting from peers for that group that you set up. And I zoomed it a little bit. It's not a high resolution, but just so you get a feel for it. These are not real numbers. It's a mock-up. But this is the view, the exact view that we're building, and you'll be able to use soon. So what's coming up next? Today, we only support content that's coming from Windows Update and Windows Store. But we realized that once you've gone through the process of setting this up and testing it and leveraging delivery optimization to reduce bandwidth consumption in your environment, you don't want to have to then move to use a different technology for different content. So we're working to expand the support from from delivery optimization to include Office 365 click-to-run updates, as well as Config Manager line of business apps that you manage through Config Manager, as well as Intune line of business apps. So we hope that that really makes it a little bit easier for you if you actually spent the time setting things up and you leverage this for all your content or your big content eventually. So in terms of supported platforms, so today, Windows Update was a Windows Update for Business, WSUS, and Windows Store, and coming soon, Config Manager, Office Click-to-Run, and Intune. And today already with Config Manager, you can use DO for express updates. In terms of operating systems, like I said, delivery optimization is a Win 10 only feature. So we're continuously adding support for additional SKUs. So in 1709, we enabled delivery optimization in Server, and Server Core and Server Nano are releasing with that. And we're going to keep adding to additional SKUs. And
I have a question around that. IoT?
Yeah, as well, coming up in future release. So we're really expanding the support for DO, and again, with the notion that you'll set it up once, and then you'll use it across all your devices in your organization and all of your content. So the recommendation or the call to action is really to give it a try. If you don't try it, we don't know what's missing, what we need to work on to make it better for you. So please give it a try. It is where all the investment in Microsoft is happening right now to build, add more features. And so we want you to try it out. And please don't ignore it. If something's broken, don't turn it off. Let us know, and we'll work to fix it. And try the group mode. It's probably your best bet. And then thank you for the two ladies that joined, because I changed the line there to say, ladies and gentlemen, please check your proxies. If you block byte range support in your proxies, it's not going to work well. DO is not going to work well. Bits is not going to work well. For apps, you're probably downloading a lot more data than you're supposed to, because we have all these Delta updating technologies that we have require byte range support. So please check your proxies. And that's it. We prepared a couple Q&As, but if anyone has questions, we can probably start with that.
Yeah, so if you have a question, is it possible for you either to come up to the mics, or because then it gets recorded? So
the tool you presented,
yep.
Where do you get the data from? Where's the analytics data coming from that you can report the graphs?
From the actual PowerShell commandlets.
So you connect to every individual PC? Or?
Yeah, so each client has an agent that basically pulls the perf snap from the PowerShell.
And then reports this from
and
the
reports
agent
it
to a central server?
Yeah.
And this is something I have to install on-premise, or is this a SaaS solution? Or a
It can be both. We haven't decided whether we should do one that people could just connect to. So we have it running in Azure today. It's basically just using SignalR as the method of delivering the message, which is same as Twitter. So it just sends little UDP messages. So we don't consider the data like vital. So if we lose a couple on the way, sometimes we don't really care.
So Microsoft had not yet decided to buy your company and include this into analytics.
No, we have a very good working relationship with Microsoft, so we're very happy about that.
We're a large company with 40,000 PCs and hundreds of sites all across the world.
Yep.
And we funnel all our internet traffic through a regional data center. Therefore, we're looking for a delivery optimization by subnet.
Yep.
I understand the group ID is what we've been instructed to do, but we don't know how to convert our subnets into group IDs. Is there any plans to make that easier for us?
I think the answer is twofolded. Like one, we should do a couple of blog posts of how you can do this in a really cool, intelligent way to set the group ID. And then I hand over to Narkis to answer the other.
So group ID is right now the solution if you need to set it, and it will require some scripting. But our team is looking at ways to be able to do this dynamically without you having to configure anything. So it would be very helpful if you describe your scenario and send an email to that alias, and
Okay.
we'll work with you on the config.
Okay, thank you. And then the second question on top of that is, suppose we do implement group IDs by subnet. What happens when a laptop that travels switches from one subnet to another? Will the policy update quick enough so that delivery optimization doesn't start downloading from its old peers from its previous subnet? Is that
So the policy, if you scripted it and it changed as the user switched network,
right?
the client will pick it up. So before we start any download, we check all the policies and adjust. So it will
Okay, thank you.
follow the
So
user.
typically, like what you can do is to use a scheduled task to detect if network changed, which is one of the common like tasks that you can trigger on, and then you set or change your group ID depending on if you had to do that. So.
So are you saying there's going to be a subnet feature put into DO? Just use the separate
Yeah,
going forward,
yeah,
like branch cache?
exactly, yeah.
I think I managed to convince her.
And then you said,
Yeah.
regarding the blog post, you said there's
Yeah, so I mean, we set the group ID today. I just want to show the download, and this is one of why it's really hard to track sometimes, because DO runs at gig speed between peers, so it's really, you have to be really fast to capture it. So, but so to answer your question, yeah, there's a lot of things you can do with group ID while being a bit smart. So, for instance, our product, if in the live mode, we set the group ID, but depending on where you are. So if you move your laptop, we reset it. But it doesn't stop that you can do the same thing. So we're not having any like special stuff. We're just using what's out there.
you and I work for the same company.
Ah.
You know, we've run across WAN issues.
Yep.
Find over here at this location, California, download somewhere way over here.
Yep.
So that's why we didn't use the LAN or the site
Yeah. So group ID is your friend.
back to
Yeah.
Yep.
May you clarify why it was decided to add delivery optimization in addition to branch caching? Is it because of additional infrastructure that you typically need to set up for branch caching, or to separate on-prem and cloud-driven
I think
implementations?
there are a lot of reasons.
Yeah,
You can
I'll
probably answer
take
some
that.
of them.
So the key reason is the need to go beyond the subnet, and branch cache using multicast for peer-to-peer connectivity requires that. So the idea in DO that we have this service that can help connect peers from anywhere to anywhere, and we're not restricted by the subnet. So that's the key reason. This is more flexible for bigger networks that we have today.
Yeah, and it also does work. I mean, you have to remember that it's the same thing that's used for consumers to download things. So, and they typically don't have any other infrastructure to respond to it, so they might want to use internet peers to get their data from it to make it go faster.
So I was just wondering why not to expand branch caching to use additional capabilities, why introducing new stuff?
Well, so I mean, we work very closely together, and there's a lot of things that are really good with branch cache, but there are a lot of things that could have been, you know, that the protocol was not designed for. And just it's not as easy to just take that code and call it a new name and add a few bells and whistles. But there are definitely lessons learned from the branch cache experience that will take over with DO. I mean, anything else would be stupid. So.
And if you've been in the sessions where we talked about transitioning from kind of the traditional IT to modern IT, we're really looking to kind of bring all these distribution scenarios to one stack, and for you to leverage those scenarios that we're building to be used by hundreds of millions of Windows clients and give you that scale. So to do that, we had to build this kind of new infrastructure to do all of that.
Basically, I consider branch caching something legacy.
I wouldn't call it legacy. I would call it almost in a prime, but there's definitely something else coming.
Okay. Thank you.
Sorry, my question's quite similar to that. You mentioned not using branch cache and DO at the same time for fear of them getting in the way of each other, but if you've still got a lot of Windows 7 devices...
So they can run side by side, definitely if you have Windows 7 devices. What I was talking is if you already have it set up and you didn't disable the DO, if you didn't set the policy to disable DO, branch cache is not going to be used because branch cache has dependency on bits for you to leverage it. So there's no interference, it's really just that we want you to be able to continue to use it if you
Unless you're
wanted
running
to.
1607 with, if it's set to disable, there's a chance DO will still kick in even with DO mode disabled, so you'll want to turn off the service.
Yeah,
We
so
got
I-
burned by that many
We got-
times.
that happened to us too.
Yeah. And so that's kind of our thing is we would really like a bits 4.0 because we use, hey, during the day only use 50 kilobits, but at night go at it, go crazy. But if you just hard limit the bandwidth utilization, all our branches have absolutely crappy connectivity compared to our central office. So if we just said use 50 kilobit all day long, a feature update, you know, in a small branch would take weeks to download. But if they leave their machine on overnight, we want them to use the full circuit. Do you see what I'm getting at? So like,
Yeah.
we'll never turn it on, not just because of that. And then again, we didn't upgrade 20,000 desktops to Windows 10 overnight. We're going to do it through attrition. So Windows 7, Windows, you know, not much 8.1, but 2008 R2, 2012, all those are going to be around for a long time, as well as Server 2016. So there's still, by not doing a 4.0, we're really limiting in terms of what we can even use this for. So we're going to stay with bits and branch cache until
Yeah, and
all
there'll
those are
probably
gone.
be a lot of companies that decide that as a strategy. I think running them two side by side is probably the best. And there's quite a lot of...
Why not just run bits for everything? So
Bits has some other issues. I mean, Bits has basically only doing one job in a round robin. And since more or less a lot of the Windows components stop doing their own thing and is using DO for their downloads, is a much higher number of Bits jobs. So if you look at Bits today, it's kind of maxed out in a way because there's even like a lot of things using it. So you can have a very high, unless you're doing,
that's good though, because we don't want it to clobber the WAN.
Yeah, people say that, but then they wonder why their Outlook address book is not syncing, because that job is really down in the pile and there's a push notifications for the tiles lying on the same priority. So unless you're doing smart stuff
Well,
with that.
We'll take that over clobbering the circuit though. That's our thing. Because I mean, like, heck, we wanted more in Bits. We want like, hey, when you do an OST download, have that go through Bits.
Yep.
You know, I mean, there's more stuff we wanted to use it, not less stuff.
Yep.
Because again, those MPLS links are just ridiculously expensive. Even a 10 meg circuit is like $3,000 depending on the location.
So all of these requirements are requirements you should feed into us, and I want to touch on the bandwidth. So setting an absolute max, that's the issue with it, right? During night, you want it to go faster. You don't want to have like a absolute. And for that, we have the percentage policy.
But so that's percentage per device or for the whole
It's
thing?
percentage per device. However, the client, when it's measuring the speed, it's also probing the download source.
Does it do a better job than Bits? Because Bits does a terrible job at that.
Yes,
Yeah, it
so
does
it definitely
much
does
better job.
much better job.
Because we could have Bits do 2%, but if there's 100 devices, that circuit's dead.
Well,
Yeah.
and that was the problem with Bits. The Bits measurement on an actual LAN speed, that's the physical NIC, which is always gig typically.
Yeah.
Then to switch then you have a crap link. So that's how the Bits policy works.
So there's a combination here of actually measuring the available bandwidth, and although it can, synchronize in real time with other devices and what they're doing, it does adjust to that. And the last thing is, we hear the feedback about the need for a policy that changes between times of days. So that's something that we're looking to add as well. And this is pretty much the last policy I think that Bits supports, and we don't. So definitely going to add that. And regarding the issue with the policy being ignored, that should be fixed in, I believe, the September quality update.
And also, if you have
please take that.
The service is much easier if you're.
And if you have a lot of, the problem with that is that could lead to that you get regular HTTP downloads instead, which you don't want.
We're using Bits, so.
Yeah, but there are other Windows components that if they can't use DO, they will go and do their own HTTP connection. So you might not see that. So, but I would definitely recommend you to check out LEDBAT to move your sources to 2016 because that will eliminate any need for, they will actually do the bandwidth managing for you.
One WSUS server for 22,000 devices.
Yep. So move it to 2016 and then you should be able to enable LEDBAT for that.
Just really simple question. For us config manager dinosaurs, how much more space percentage-wise are Express updates going to add to my update store?
To the WSUS servers?
I would count 8 times.
8 times?
Yeah.
Yeah. When we downloaded each month of updates, when we download just on pure WSUS, it's hundreds of gigs each month.
Yeah.
Unless you have just one OS. But if you have a bunch of OSs,
But it depends on the languages that you select,
Yeah.
versions
Like-
that you want.
yeah, like
So it
12.
depends. So it's like,
Yeah. So make sure you clear out the old stuff as fast as you can, and you know, as Oracle used to say, disk is cheap.
But at the same time, on the clients pulling the update from the WSUS or the config manager, that's somewhere around 100 to 200 megabytes instead of 1 gig. So, you know, you make the kind of the choice.
Yeah, but I mean,
Yeah.
eight times is more than we've got on the data stores in most regions.
Yeah.
It's just not.
Yeah, but you have to also imagine that it does the same thing on the download size, though. So it will cap. I mean, if you get, if it, the, I mean, 8-fold increase in size, it's then cutting the download size by 8.
I mean, at that point, why even download and distribute the content? Just turn on the ability to download from Windows Update, leave the
Yes.
Express update on, and then they're on the site server. And I guess they just use the hash that you're hosting rather than branch cache having to calculate it,
Yep.
and then download just Windows 7 separately.
Yeah.
Sorry, this was maybe a simple question.
My question is real quick. Is obviously we have like heavy performing laptops and desktops on our network. They do roam and stuff. We do have a lot of people doing video editing, Excel spreadsheets that take 3 days to process. What in this process is really going to look at, or if anything, you know, hey, look, this thing's spiking at 80% for the last 24 hours. You know, what is managing it so that I'm not fully taxing a system that's already pretty taxed as well, that it's not going to impact, you know, a download for video editing, reprocessing, and sending it back out. That was my question.
So we consider all the peer-to-peer upload activity as a background or low priority activity. So we hook up to the system and we get alerts if there's a memory resource or congestion using NetBat on the network. We're just going to dial back all this peer-to-peer activity. So it does adjust to those constraints. But
So the server manages.
the client that's running on the machine itself is aware of the resources, and all the threading and all the disk I/O that we do, it's all in low priority. So it's trying to be a good citizen.
Okay. And then when we're doing WAN optimization, those types of things, is that going to have any impact on this at all, or no, it doesn't care?
So it's going to use what you're going to give it, right? So if you restrict our HTTP traffic, we'll just use what we get. I'm not sure how it's going to impact the peer-to-peer, the TCP activity between the peers. If you'll throttle that, we might end up choosing more of the HTTP because we'll assume it's a better resource.
Okay. And is there any weights that go along with this as well? Because I know, like, you know, does it say, hey, look, this one's this one's a little bit closer, that one's a little bit further away, I'm going to grab this one first?
Yeah,
it
so
does do automatic weights.
it connects to all these peers in parallel and tries to use more than ones that are giving the better speed. And the client has this minimum download speed that it's trying to achieve,
Right.
and it's trying to maintain that. So if the peers just are not giving enough speed, it's going to take more from the HTTP. If there's a really good peer, it's going to shift to use that more.
Okay, thank you guys.
And that's typically what you had on the slide here, is that I had a really good peer. So we got it at like 300 and probably about 400 megabit from the other peer. So even a gig game takes like a second to download. Meanwhile, if you use branch cache to do that, branch cache is capped at around 50, 60 megabit to go in the background. So there are a lot of people running bits and branch cache that wants to go faster, and the machines are more capable. So DO will be able to do that, but at the same time can actually run slow in the background.
I just want to know, is there any way of getting reporting out of all this or notifications? I use WSUS and the reporting is just absolutely, doesn't get anything. So is there a way to...
Only WSUS, no config manager?
That's correct.
Yeah, so we have a reporting infrastructure that will be able to do that. You'll get some with the OMS, and we're talking to see if we can work together on some of that. But so we have a separate database that you can put in.
So you will be able to use Windows Analytics even if you didn't onboard to Windows Update for Business, and you can just start using it to see the performance once we have it, even if you're downloading from WSUS.
And like email notifications and stuff like that will be...
So
will be set up?
that's not part of the suite. It's more of you go in and you have the ability to look at this aggregated data or drill down to a device level data. But I
So all
want to be alerted if your caching efficiency is dropping or if it's not meeting your expectations, you can have it send your an email or something.
Great.
So to repeat that for the recording, OMS does have the ability to set alerts and trigger based on value drop or things
Thank
like
you.
that.
You're welcome. Any other questions?
Can you show the previous slide?
You're welcome.
Thank you.
Is that the slide you wanted?
Yeah.
Yep, good. Yeah, if you have any other questions but are afraid of the mics, you can come up afterwards and grab us.
I'd still like to see the download.
Yeah, you're not alone on that.
I think it was the one with the 70 megabytes.
There were a few I did.
It was the game with the racing game with the 70 meg.
Well, so we
You
can
want to
take.
just try another game on the
I
seed?
don't.
and
I
then-
did some. I wasn't really paying attention to it though. So, but I can switch over to show
8.
8. Yeah. So we only show real-time data, but let me do this into a format table. You should be able to see. So
Yeah, now it's showing.
yeah. So it gives you a pretty good way of determining where the actual bytes came from. So
And all you need to do this at home, if you have 2 machines running one of the latest Windows 10 builds, just go download an app, wait, download on the other machine. The reason you need the latest releases for the PowerShell commandlets, those are in the 1703 build. So that should be an easy way for you to see what's happening behind the scenes.
but typically, I'm a bit surprised why my demo has been a bit, not as it should have been. Because this is an actual see if I can zoom in even more. This is an actual download that is running simultaneously. So you can see it was supposed to download about 2 gig, I think was the total file. So like one of my games. And even if you started the 3 machines immediately at the same time, you can see that it was fast enough to know that the other machine had the content. So I don't know if there's some things that changed or if my Wi-Fi is too slow so it doesn't send up the data back to the DO servers so that it knows, or something else. Because typically in my lab, it kicks off straight away. So you can start one download and then you just wait like 1 second and then start it on the next one, and DO already knows about it. So, and I don't know if it's extra load because it's so much inside traffic going through DO at the moment. I had to stop my machines they were trying to upgrade yesterday, so to run to the pause. So, but typically it's super fast. You're welcome.
Thank you.